Welcome to GrayYeon Math. We are asked to solve this problem. We have a green semicircle, and inside this green semicircle is a smaller semicircle, which is the yellow one, and inside this is also a blue circle, which is tangent to both of this yellow semicircle and the green semicircle. Okay, so the diameter of the yellow semicircle is uh, 4, and the distance from the diameter to end of the diameter of the yellow circle to the end of this diameter of this green semicircle is 2, and we are required to find the area of the blue circle. Okay, so for this type of problem, so we are required to search for right triangles, and from that right triangles, uh, we need to form that, we need to draw lines inside this and identify the points of tangency. So this one is a point of tangency, this one. So we can draw a vertical line from the center of the blue circle downwards. And from the center of this blue circle again to the center of this yellow semicircle. Okay, so since we are after the area of the blue circle, we represent the radius of this blue circle as r and r. And since the diameter of this yellow semicircle is 4, then the radius should be 2. So we just need to divide it by 2. Okay, so, and we actually form a right triangle, but we are lacking about this distance. So we have to find a way to represent that distance. Okay, so next is I want you to notice that the diameter of the whole green semicircle is 6. So 6. So that is the diameter. So the radius should be, let's call this as capital R. So the capital R radius for the green semicircle is should be 3. Okay, so let us point out this to be it is somewhere here, the center of the uh, green semicircle. So if you have this uh, length of the diameter of the yellow, so the radius should be 2. So, and if this is 2, and you have to subtract 3 from this radius of the green semicircle, then this should be 1. Okay, and we represent this distance, this unknown, to be A. This is only the unknown because know that we already know that this should be 1 because the radius is 3 for the green semicircle. Okay, so next is I want you to notice that since this is the center of the biggest semicircle, we can actually draw a line that will be the radius of this big semicircle, and it will of course pass through this center of the blue circle towards its uh, this point. So since this is r, and the radius of the biggest semicircle, the green semicircle, is 3. So we need to subtract r from that. So we have here the hypotenuse as 3 minus r. Okay, so next is I want you to focus on this highlighted triangle, and the sides are in the boxes, the red boxes. So to isolate, so uh, we want to get a value for the a. So let us say that is a square. We need a value for a. So a for the representation, a square plus r square. is equal to 3 minus r square using Pythagorean theorem because it is a right triangle also. Okay, so a square plus r square is equal to 9 minus 6r plus r square. Okay, so we simply cancel this r square and a square is equal to 9 minus 6r. Okay, so next is I want you to focus on this highlighted the previous triangle, the larger right triangle we got earlier. So the hypotenuse is r plus 2 and the longer leg is a plus 1. As you can see, we need to include this 1 unit length, 1 unit segment, and the shorter leg is r. This r plus 2 hypotenuse and this longer leg. So we need to make an equation by Pythagorean theorem. So we have a plus 1 square plus r square is equal to r plus 2 squared. So a square plus 2a plus 1 plus r square is equal to r square plus 4r plus 4. So we simply cancel this r square and we simply earlier we got a square is equal to 9 minus 6r. So 9, we replace this a square by 9 minus 6r. So 9 minus 6r plus, and we copied the rest. So 2a plus 1 equal to 4r plus 4. So next is we simplify things. So 9 plus 1 is 10. So we combine this and subtract this 4. So 9 plus 1 is 10 minus 4. This becomes 6. Okay. So and next is we copy this a plus 2a and we put this r to the right hand side. So we have is equal to 4r plus 6r. So that gives us 10r. So and actually we can simplify this by multiplying this by 1/2. So we have 3 plus a is equal to 5r, or a plus 3 is equal to 5r. Okay, so next is we go back with a square is equal to 9 minus 6r. And earlier we got a plus 3 is equal to 5r. So, or we can write this as a is equal to 5r minus 3. So we can simply substitute this into this equation. So that becomes a square. So a will be 5r minus 3. So 5r minus 3 square is equal to 9 minus 6r. Okay, so 25 r square, squaring that binomial, then it will give us plus for the second term, we have negative 30 r plus 9 is equal to 9 minus 6r. And we simply cancel this 9. And therefore, we have 25. We just copy this r square and we put this negative 6 to the left hand side. So we have this becomes positive. So negative 30 plus 6 will be negative 24 r is equal to 0. Okay, so now this becomes a quadratic equation and we simply solve this resulting quadratic equation. So we simply factor out r and inside we have 25r minus 24 equal to 0. So we have two solutions actually. So one is r is equal to 0 and r, or 25r minus 24 is equal to 0 and r is equal to 24 and we do 25r is equal to 24. So we simply divide both sides by 25. So we have r is equal to 24 over 25 units. And we simply get this positive solution, not the zero, because there is no zero distance. So r is equal to 24 over 25. Okay, so for the final step, since we are required to find the area, simply equal to pi r square for any circle if the radius is given. So area is equal to pi times 24 over 25 squared. So area now will be equal to this 24 square becomes 576 over this 25 square becomes 625 pi square units. And that is our answer. So thank you for watching until the end of the video. Please like the video if you like our solution and don't forget to subscribe to the channel and hit the bell icon so you will be updated for more math videos like this. Thank you. Bye.